Hi everyone, my name is Yebo Feng, a PhD student from University of Oregon. In this post paper, we are going to present approach to detect cryptojacking traffic. Uh, the title of our post paper is Content-Agnostic Identification of Cryptojacking in Network Traffic. Two co-authors of this paper are Devkishen Sisodia and Jun Li. So without further ado, let's start. First of all, let's talk about cryptocurrency mining or crypto mining. As the blockchain system becomes more and more popular, more and more people began to be familiar with the concept of crypto mining. Crypto mining is actually a very essential component of the blockchain system. It validates the transactions and adds valid transactions to the blockchain. It often divides a mining task among mining devices in a mining pool, and it provides a means for cryptocurrency to establish consensus. And of course, it requires significant computing power to operate. It enables miners to make money via transaction fees or the generation of new blockchain coins. Due to the tremendous gain of crypto mining, a new type of malicious activity called cryptojacking began to draw people's attention. Cryptojacking is a term defined as unauthorized use of somebody else's computing resource to mine cryptocurrency. Usually, the hackers will send people a malicious email link, and once the user clicks the email link, it will download a crypto mining code and run it in the background of the computer, and it will automatically mine cryptocurrencies for the hackers. And also, hackers may create a website with crypto mining code embedded. Once people go to that website, the browser will automatically use the user's computing resource to mine cryptocurrency for the hackers. And sometimes hackers will simply infect the machines with crypto mining code via malware or worms. So there are a bunch of ways to conduct cryptojacking. According to a survey from Cyberbit, cryptocurrency mining software was installed on more than 50% of one airport's workstations. The situation has been there for months. The hackers just use the computing resource of the airport to gain cryptocurrency for them. Recently, researchers also uncovered the first instance of a new cryptojacking worm that propagates via malicious Docker images. So in this case, the attackers just put the cryptojacking softwares in some very popular Docker images. Once other developers downloading that Docker images and deploy the Docker image on some servers, it will just automatically run the cryptocurrency mining software in the background and use the server's computing power to help the attackers gain the cryptocurrency. As the crypto mining problem becomes more and more serious, the security community has proposed many solutions to tackle this problem. The majority of the existing solutions are endpoint based, which means the users have to install some detection or anti-malware software on their computer. There are some anti-cryptojacking extensions on web browsers which detect cryptojacking scripts through mining code patterns. Besides, there are some antivirus softwares which are capable of detecting cryptojacking activities. They monitor the abnormal use of computing resource or detect the cryptojacking malware patterns in the system background. However, those solutions are all endpoint based, which means if you want to get a very comprehensive defense, you have to install such solutions on every endpoint based devices. Which is almost impossible in reality. There are also some network-based solutions. Some of the solutions filter the traffic with a blacklist of the mining pools. Some of the solutions use deep packet inspection on the packets sending from the users to the mining pool. However, such solutions cannot tackle the very smart attack. For example, the attackers can frequently change the IP address of the mining pool. The attacks can also encrypt the mining messages sending from the users. So what we are proposing as a flow-level privacy-preserving cryptojacking traffic detection, it does not need to utilize a blacklist of the mining pool or do deep packet inspection on the packet messages or payloads. Here is the operational model of our approach. It can be deployed as a border router of a campus, company, or institution level network. Our approach only captures 4 types of information from the inbound and outbound traffic, which are the source and destination IP addresses, source and destination port numbers, protocol, and packet size. Our approach does not need to capture the payload of the packets, so it is privacy preserving. It does not need to know what type of messages you are sending to the server. And once it is deployed as a border router, it can efficiently protect the whole network behind the border router. Before jumping into the detail of our approach, let's first do a brief study of the mining traffic. Usually the mining traffic between the miner and the mining pool contains 5 types of messages, which are login message and login confirmation message, and also most importantly assignment allocation. It's sending from the mining pool to the miner, tells the miner what tasks you are going to operate. And once the miner figure out the results, it will send out the result message, and the mining pool will reply with result confirmation message. Here is an example of the mining traffic. The upper plot shows the outbound traffic, which is the traffic sending from the miner to the mining pool. The plot below shows the inbound traffic, which is the traffic sending from the mining pool to the miner. The red bar is the result submission message. The purple bar denotes the assignment allocation messages. The y-axis of the plots shows the sizes of the packets. If we do some very simple pre-processing, we use Gaussian filter to smooth the packet intervals. We can clearly see the periodical trend of the mining traffic. The assignment allocation message is much more frequent than the result submission messages, because the mining pool needs to make sure the miners can always have the most up-to-date tasks to work on. And once the result submission messages are sent out, we will immediately see result confirmation messages sending from the mining pool to the miner. And we can try to use such features to detect crypto mining and cryptojacking traffic. The detection of crypto mining traffic is easy, but we want to do one step further. We want to detect the cryptojacking traffic. To do so, we need to get clear with one concept, which is hash rate, the speed at which a device is completing an operation in the crypto mining code. After studying the cryptojacking activities, we found that cryptojacking activities differ from the legitimate crypto mining activities in the following aspects. First of all, the hash rate of legitimate crypto mining is more stable than the hash rate of the cryptojacking, because cryptojacking scripts usually relies on some existing software running in the system, such as a browser or terminal, which makes the computing resources devoted to the mining calculation unstable. Secondly, the hash rate of cryptojacking is usually lower than the hash rate of legitimate crypto mining, since cryptojacking scripts or malware cannot easily invoke GPU or dedicated ASIC chips to mining, further leading to a lower message rate. To detect the cryptojacking traffic, we apply the fast Fourier transfer to convert the packets from the time domain to a representation in the frequency domain. The traffic generated from other activities, such as browsing web pages, DNS queries, or telnet remote controlling, tends to have very complicated and randomized frequency patterns. Conversely, mining traffic has clean and periodical frequency patterns. In such case, we define a sliding time window to monitor the ongoing traffic. For each sliding time window, we convert the packets from the time domain to the frequency domain, and we then use a threshold-based matching to detect the crypto mining traffic. To further identify the cryptojacking traffic, we capture the hash rate differences between different time windows. In this case, are the frequency differences, and we just extract those frequency differences as a vector and input those vectors into an LSTM model to detect cryptojacking traffic. Here is the LSTM classification model we use. We just input the frequency differences, which are Rn and An, to the LSTM model, and we train the classification model with collected crypto mining traffic data, which are the legitimate crypto mining and cryptojacking traffic. The LSTM model outputs two types of labels, legitimate crypto mining traffic and cryptojacking traffic. It will continuously monitor the ongoing mining traffic until it identifies, oh, it's cryptojacking or it's legitimate crypto mining traffic. Here is the conclusion and future work of our approach. So in this post paper, we propose a privacy-preserving cryptojacking detection approach that only relies on content-agnostic network traffic flows to conduct the detections. Our approach is efficient and easy to deploy. With the computing power of a personal computer, it is capable of providing real-time detection of cryptojacking for a company-level network. So in the future, we will keep on simulating the cryptojacking activities on different platforms and collect their traffic to improve and test our approach. So thank you for listening to this presentation, and we would like to thank Ripple to provide fundings to support this research. Just feel free to ask if you have any questions.